Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. I have brought a series for ISI preparation and also for CMI in which I am discussing many important topics, subtopics and questions which will definitely help you in your exams. This is actually continuation of our KVPY series in which we have already discussed many important topics, subtopics and questions. So you can go through them also. In today's session, I will discuss PnC, in fact some important questions on PnC. I have already taken 2 sessions in that KVPY, so please go through them, it will be very helpful for you. So let us start the session with this question. Here we are asked actually the coefficient of a cube b power 4 c power 5 in the expansion of bc plus ca plus ab power 6. Now I have two methods to do this question. Let us see how this can be done. So my first method is method 1, that I take abc common from inside. A into B into C common from the inside, because power is 6 on this bracket, so outside it will be A power 6, B power 6, C power 6, and we will be having here A power minus 1 plus B power minus 1 plus C power minus 1 whole raised to the power 6. Now we are looking for the term of A cube plus A cube into B power 4 into C power 4, and this term will be actually equivalent to, if I look only in this bracket, because this a power 6, b power 6, c power 6 is taken common, this will be equivalent to a power minus 3, b power minus 2, c power minus 1 in this bracket of a power minus 1 plus b power minus 1 plus c power minus 1 whole raised to the power 6. And now there is a direct use of formula, because this is a multinomial. This is the concept based on multinomial theorem, where we have to find the coefficient of a power minus 3, which I can take as a power minus 1 whole power 3. Similarly, b power 2 can be taken as b power minus 1 whole raised to the power 2, and c power minus 1 whole raised to the power 1. So the required coefficient would be 6 factorial upon 3 factorial, 2 factorial, 1 factorial. If I multiply by 3 in numerator and denominator, it can be seen that it will become like this, which is nothing but 3 into 6c3, and that is the answer. So answer here would be D. That is one way. Let me tell you how this result comes. Many of you may be thinking that yes, there was a formula, but how does this come? Let me tell you. We are looking for a cube, a power minus 3, b power minus 2, c power minus 1 in this expansion of a power minus 1 plus b power minus 1 plus c power minus 1 whole raised to the power 6, which I can write as a power minus 1 plus b power minus 1 plus c power minus 1, one bracket, similarly another bracket, and I will write such brackets 6 times, 2, 3, 4, 5 and 6. Now, how do we get a power minus 3? I think I need to choose 3 brackets out of these 6, where I will multiply a power minus 1 with a power minus 1 with a power minus 1, which will give you a power minus 3. So what we need to do, we need to choose 3 brackets out of 6 where terms of a power minus 1 will be multiplied. Now from the remaining 3 brackets, I will be multiplying b power minus 1 2 times. So I need 2 brackets out of 3, which will be chosen in 3C 2 ways, where b power minus 1, b power minus 1 will be multiplied, and then the remaining bracket we will be multiplying c power minus 1. So that is 1C, one way to choose that bracket. So you can see this is also giving you your desired answer or required thing. So answer here is 3 into 6C3. Actually, this method here is the proof of this coefficient in a multinomial theorem. Okay, now I would like to discuss one more method. It is not that efficient, but still there is another method. Let us see what it is. We can think of that general term in the expansion of given bracket is bc raised to the power p, ca raised to the power q, and AB raised to the power R. And coefficient would be 6 factorial upon P factorial, Q factorial and R factorial. Now, in order to get this, we need to compare the powers, which will give you three linear equations. Power of A is Q plus R and it should be equal to 3. Then R plus P is equal to 4 and P plus Q is equal to 5. And solving them, we will get P is equal to 3, Q is equal to 2 and R is equal to 1. And hence the required desired coefficient would be the same thing, 6 factorial upon 3 factorial, 2 factorial, 1 factorial. And this gives you the answer 3 into 6, C3. Okay, so this completes the solution of this question. Coming to the next question. The next question is, consider a sequence of 10 A's and 8 B's placed in a row. By run, we mean one or more letters of same type placed side by side. Here is an arrangement of 10 A's and 8 B's which contains 4 runs of A. And what are 4 runs? Please understand. 1, 2, 3, 4. And 4 runs of B. And what are 4 runs of B? I think this is 1, this is 2, this is 3 and this is 4. Now the question is, in how many ways 10 A's and 8 B's can be arranged in a row so that there are 4 runs of A and 4 runs of B. Now let us understand how this can be done. Okay, so I need 4 runs of A and 4 runs of B that should be alternative. Okay, then only you will be able to differentiate between one run with the another run. Okay, so my first run of A, let us say, is here, then first run of B, then second run of A, second run of B, then third run of A, then third run of B, then fourth run of A and fourth run of B. Now we have to place A's and B's in these places so that number of A's are 10 and number of B's are 8. So I think this question can be done very easily with the help of distribution of alike objects, or we popularly know that thing as Beggar coin method. So let us assume that at first place I am going to place X numbers of A's. At second run I am going to place Y numbers of A's. Similarly, Z number of A's and W number of A's. And as you can see, this X plus Y plus Z plus W has to be equal to 10 because we are given 10 number of A's. But here, as you can see, at least one of A should be placed at each place designated for what we are calling as run of A. So X, Y, Z and W has to be at least 1, 1, 1. So in such question, there is a direct formula for this also, but I always suggest that you remember this type of question with that you have to give 10 coins to 4 beggars such that at least 1 coin is going to be given to each beggar. So what we will do, we will give 1 coin to each beggar, and my new equation will be X dash plus Y dash plus Z dash plus W dash, and this will be equal to 6 because we have given 1 coin to each of these X, Y, Z and W, and now new variables are X dash, Y dash, Z dash and W dash, and now condition on X dash, Y dash, Z dash and W dash will be that they are greater than or equal to 0. So number of solutions of this, let me call this as equation 1. So number of solutions of 1 would be, as you know, 6 plus 6 is the number of coin, n plus r, which is number of beggars, minus 1, c r minus 1. So we will be getting this as 9 c 3. Similarly, for B, if we look at, so let us consider P number of B here, Q number of B here, R number of B here and S number of B here. So here P plus Q plus R plus S has to be equal to 8. And as once again P, Q, R, S has to have at least one value with them. So here we will be giving 4 coins to these 4 beggars. So here there will be 4, or you can write that equation once again, P dash plus Q dash plus r dash plus s dash is equal to 4. So number of solutions would be 4 plus 4, 8 minus 1, 7, C3. Okay. Now one more thing here to notice, that they have not said that we should start with A only. We could have placed B first, then A, then B, then A, and so on. So in that case, we will have two different arrangement. The only difference would be that in one of them you will start with A, in another one you will start with B. Same number of A's and same number of B's can be placed in their um, in their run, as they are saying in their run. So I think the answer would be, so the final answer would be 2 into 9C3 into 7C3. I am repeating why I have done 2. 2 is for that whether we are starting with A or we are starting with B, and 9C3 is to place A at the 4 runs of A. Similarly, 7C3 is the number of ways to place 4 B's, is to place 8 B's at 4 runs of B. So the answer here should be. Now coming to this question, which says 4 letters 2A and 2B are filled into 16 cells of a matrix as given. It is required that each cell contains at most 1 letter and each row or column cannot contain same letter twice. The number of ways this matrix can be filled is. Please understand. We have to fill such a way that suppose my A take place in this cell, then this cell will not contain other letter, maybe A or B, because at most 1 letter is to be placed in each cell. And also they have given each row or column cannot contain same letter twice. That means these 3 places or these 3 places cannot have second A. These out of these 6 places you can have B here, because then this second column will have 2 letters but they're different. You cannot have same letters A in same column or in the same row. That is the condition. So this is how we have to fill. Let us see how to do this question. I have 2 methods to do this. Please understand. First, I will be filling A's and I have 4 rows, 1, 2, 3, 4. So these 2 A's can go in 2 different rows, and which 2 rows I think we can choose in 4C2 ways, maybe first and the last one. And then we will fill first row with A in 4 ways, because I have all the cells empty, so maybe I can keep my A here. So 4 ways to fill first row, and after filling this A we cannot put my other A here, so I'll have 3 options only for the second A. So total would be 6 into 4, 24 into 3, that is 72. So here 72 ways to fill the 2 A's. Let us assume my second A is here. Now, once we have filled the 2 A's this way, I have taken one of the example of these 72. Now, how to fill the B's? Now, I have made 3 cases. Please see what are these 3 cases. I will first put my B in those cells in which no A has already taken place. Okay. My second case would be I will fill my B in those rows only in which already 2A has taken place. And then I will take the case in which one of the row would be in which A has not taken place, and one of the row would be where A has taken place. This is how I am going to do, so that no repetition or no case will be left out. Now in the first case you can see, I think to place 2 B's would be 4 into 3 direct, isn't it? Because my first row I have 4 ways, maybe let us put B here, and then I will have 3 ways to fill B's, and I can place any at any place I can place this B. So total number of ways will be 12 to fill B, such that they come in those 2 rows in which 2 A's has not taken place. Now in the second case, here I have 3 places to fill first B, and then 3 places to fill second B. But there is small change, small catch. You can see that suppose you fill B here in the first row, which is I think done in one way, then you will be having 3 places for second B. You can check. Even here we can place B, though they will have this A and B will be in the same column, but that is permitted. So after putting B in this place, which is directly above this A, I think I have 3 choices to fill B. But if my B was not here, if it was here or maybe here, then you can see we will not be able to place B here, we will not be able to place B here because already A is there. So in that case, I will have 2 choices only. So if my B is at this or this place, you can see, which is done in 2 ways, then we will have only 2 ways for second B. So in this case, where 2 B's are taking those rows in which A has already come, I think answer would be 3 plus 4, that is 7. Okay, now coming to that case in which one of the row is in which A has already taken place and another row where A has not taken place. So first of all, which row in which A has already taken place? I think 2 ways. We could have chosen this row also or this row, so 2, and then 2 ways for choosing that row where A has not taken place. Then we can place B at any of the 3 places here. Okay, and let us say I have put B here, then I will have 1, 2, 3 places to fill the other B. So you can see it will give you 36. So what will be total number of ways? Total will be 72 first for placing A, and for every such filling of A, I think we will have either 12 or 7 or 36. So this becomes 72 into 19 plus 36 is I think 55. So this becomes 36 into 110, and you can check it becomes 6 here and 390 here. So 3960 will be the answer. So that is one method. I'll tell you one more method, please see. In this method, first of all, I will place A in the same way 4C2 into 4 into 3 as I did in our first method. So let us say this time 1A is here and 1A is, let us say, here. Okay, so 4C2 into 4 into 3, that is I think 72. Now, after filling these A's here, I think we are having 14 remaining cells. 14 remaining cells. So what I can do, I can choose any 2 of these 14 cells where I will put 2 B's. So 14C2. But as you know, we want no 2B going to in the same row or into the same column. So that I will subtract. So what cases I have to subtract? I have to subtract those cases in which 2 B's are going into the same row or into the same column. Now, which 2 rows? Please understand, I have 2 kind of rows now. One where A has already taken place. So if I have to place 2B in such row where A has already taken place, so first of all, which row you will choose, this one or this one. And for every such selection, we have 3C2 ways to fill 2 B's in that row. Okay, similarly, we can fill 2 B's in those rows in which no 2A has taken place. So here I think it will be 2 ways which row you want to put that B, and then 4C2, because we have 4 places here, 4C2 ways. So I think it will be 12. Okay, now this same thing can be done in columns also, but I think this we can do in one way. We can count that column cases by just multiplying by 2. So my final answer would be, please understand, I'll just repeat, 72 is for placing 2 A's. Then without considering whether 2 B's are going into same rows or not, or same column or not, then it will be 14C2. Then minus, this is how much? I think 6, this is 12. So 6 plus 12 are the ways where 2 B's will go in the same row. 6 plus 12, that is 18. And same will be for columns also, isn't it? That if I'm placing 2B in the same 2 B's in the same row, the same condition will be there in the column also. So we just have to multiply this 6 plus 12 by 2, and that will give us the answer. You can check. 72 into 14C2 is I think 91 minus this will be 36. You can check, it comes out to be 72 into 55 only, which we have done here also. So answer in this manner also we are getting 3960. Okay. Now coming to this question, one very interesting question. It says n is equal to 2 power 31 into 3 power 19. We have to find positive integer divisors of n square that are less than n but do not divide n. Okay, so first of all, let us understand how many divisors are there for n square. I think n square means it will be 2 power 62 into 3 power 38. So number of divisors will be 63, that is 62 plus 1, into 39, that is 38 plus 1. So that is the total number of divisors of n square. Now you can see this product will be odd number, and as you know, number of divisors for a perfect square is always odd. It can be seen from this formula also, because for any perfect square number, these powers will be even, and as the formula says, power plus 1 into power plus 1 and so on. So it has to be odd number always if this number is perfect square. Now there is one more method, one more way to look at this, and that is very important for this question also. Please see, if I write all the divisors of n square in the decreasing order, I think my first divisor, let me call this as d1, then d2 and so on, and in the last, let me call this as d of 63 into 39. Okay, and I am sure you all understand this first divisor d1 is nothing but n square itself. Okay, and the last divisor is nothing but 1 only. Okay, now you can see the product of the largest divisor and the smallest divisor is n square, and it has to be always, isn't it? Like see, because every divisor will be able to divide n square, and the quotient you will get will also be the divisor of n square. Suppose if I divide n square by d2, okay, then we will be getting some quotient, let us say q. Don't you think that this q will also be a divisor of n square? Now because d2 is the second largest divisor, so q will be the second smallest divisor, isn't it? So this q will be here. You can write this as d63 into 39 minus 1. Okay, now one more thing. In between there will be n also. In between there will be n also, that will be lying just midway of this 63 into 39. So what I am trying to tell you here, that if I focus on those divisors which are less than n, which is asked in the question, they will be lying on the right of n in this series, you can say. Okay, and how many divisors will it be? I think if I leave this n apart, so total number of divisors will be 63 into 39 minus 1, and half of them will be lying on the right of n, which is actually lesser than n, and similarly half of them will be bigger than n. Let us focus only on those divisors which are less than n. But they are asking for those divisors which do not divide n either. Okay, now there can be some divisors like 1, you can see, will be dividing n. So how to find which all divisors are there which will not divide n? To do this, I will take the divisors of n. So this n is 2 power 31 into 3 power 19, and for this number of divisors would be 31 plus 1, that is 32, and 19 plus 1, that is 20. So total number of divisors are 640. Okay, and out of this 640, if you see, 639 are less than n, yes or no? Are less than n, because this 640 also includes n. So those divisors of n which are less than n are 639. And also one more important thing, that all divisors of n are also divisors of n square, isn't it? So these 639 divisors which are less than n will also divide n square. Okay, so if I focus on those divisors which divides n square and less than n, which we have already calculated, they are 63 into 39 minus 1 by 2. Okay, and if now I subtract 639, please understand why I am subtracting 639, because out of these number of divisors 639 are also there because they also divides n square. Okay, and we are looking for those divisors which do not divide n. So if from these all divisors of n square less than n, if I divide those divisors which divides n, I think we will be able to get the desired number, isn't it? And this is how this question can be done easily. Okay, and I will leave this question for you to solve it, but let me tell you, there is one very simple calculation for this question. To do this question for general way, suppose this is 2 power p and 3 power q. Okay, then what will be my expressions? Please see, you can see it will be 2p plus 1 into 2q plus 1 minus 1 divided by 2 minus p plus 1 into q plus 1 minus 1. Okay, I think that is what we are doing. If n is 2 power p, 3 power q, then n square will be 2 power 2p, 3 power 2q. So this 63 into 39 minus 1 upon 2 can be thought of like 2p plus 1 into 2q plus 1 minus 1 upon 2 and so on. So if you do this calculation, I think you will be able to get this as 2pq plus p plus q. 1 is already cancelled, and minus here it will be pq plus p plus q. 1 is also cancelled, and you can check it comes out to be p into q. So what we need to do, we just need to multiply 31 with 19, and that will give us the answer. I will like to do this question in another method. Please see what this is. We have to find those divisors which are less than n but do not divide n. Okay, so please understand, if they do not divide n, then it should be of the form where power of 2 is bigger than 31, a is some positive integer, or power of 3 is bigger than 19. Both cannot happen simultaneously, but at least one of them should have power bigger than 31 or 19, then only it will not be able to divide n. We want such divisor to be less than n, so the power of 3 in first case has to be lesser than 19, and in the second case power of 2 should be lesser than 31. Then only there will be a chance that these divisors becomes lesser than n. But there is one more condition, please understand. In this case 2 power a should be lesser than 3 power b. Then only this number will be lesser than n. Please try to understand. We are multiplying this n by 2 power a, and we are dividing n by 3 power b to get this divisor. And if we want this to be lesser than n, then 3 power b has to be bigger. Similarly here, this 2 power a has to be greater than 3 power b. Then only this divisor will be lesser than n. Okay, now what are the conditions on a in both the scenarios? Please check. Here a has to be, I think, less than 31, then only it can divide n square, and it has to be greater than or equal to 1. This is the condition for a in first case. And the condition on b in the first case, I think b has to be lesser than or equal to 19. It can be 19 also, but it has to be bigger than 1. You cannot take this to be 0, because if it is 0, then it will become 3 power 19, and because a is positive, so here this will become bigger than n. So b will be within 1 to 19. Okay, and I think same is the condition on a and b in the second scenario also. Okay, now please understand what we are going to do. So you can see that we can have divisors of two types. Okay, one in which power of 2 is increased and second in which power of 3 is increased. But in both of them, the condition on A are like this. Okay, we need not to check whether 2 power A is bigger than 3 power B or 2 power A is lesser than 3 power B. We are 100% sure that 2 power A cannot be equal to 3 power B for any positive integer A and B. Yes or no? So that is clear that whatever A you choose from this or whatever B you choose from this, 2 power A and 3 power B are going to be different. Now if 2 power A is bigger, make a divisor of this type. If 2 power A is lesser, then make a divisor of this type. So we have 31 into 19 ways to choose A and B, and based upon 2 power A is bigger or 3 power B is bigger, we will be able to get exactly one of the divisor which will have this property that it is less than n but do not divide n. So this way also I think it is direct that 31 into 19 is the answer. I think in the previous way also we got the same answer. Okay, now coming to next question. I think this question is similar to what we have done before. Please see what this is. In a sequence of coin tosses, one can keep a record of number of instances where a tail is immediately followed by a head is immediately followed by a head, etc. Followed by a tail is immediately followed by a tail, and head is immediately followed by head, and etc. We denote them by th. This is tail followed by head, and hh when head is followed by head. For example, in this sequence you can check of this 15 coin tosses, we observe that there are 5 HH. Let us see what are these 5. 1, 2, I think 3, and this 4, and this 5. Yeah. So if there are 4 H together, I think they will give you 3 instances of HH. Similarly, 3 HT, it can be checked 1, 2, 3 HT and 2 TH. One is here and one is here, I think, TH. Yeah, no other TH. And 4 TT subsequences. We have to find how many different sequences of 15 coin tosses will exactly contain 2 HH, 3 HT, 4 TH and 5 TT subsequences. I think this question is very much similar to what we discussed earlier also, but let us do this question also. Please see, if we want 3 HT, that means I have to have one, I think we used a term run of A and B's. So if I have one run of H here, then there will be another run of T, and at their junction you will find one HT, isn't it? Then similarly, then there will be one more run of H. This will give you one TH sequence. We want 4 TH, we want 3 HT. So let us see how it can be done. So if I write HT, HT, H, so how much HT I have got? 1, 2. I have got only 2, and TH also I have got 2. Okay, let us write one more T here. Then we will be having 3 HT sequences, 1, 2 and 3, and we want 4 TH. So far we are having 1, 2. Okay, so I think I should put H here also so that we will be able to get 4 TH. Let us check 1, 2, 3. I think 1 T will be here also. Now I think 4. 4 TH, 1, 2, 3, 4, and HT would be 1, 2 and 3. Yeah, 3. So you can check that if I add few more T here or here or here or here, they will not make any difference to HT or TH sequences. They will only make difference in the HH sequences or TT sequences. Now because we want 2 HH sequences and we want 5 TT sequences, so please understand, so far if only one H is placed at these places which we have called as run, I think there is no 2HS sequences. So what we can do, we can either put 2H together at two places like this and here. So two HS sequence will be here and one HS sequence will be here and one HH sequence will be here. So this will give us 2, or we can do one more thing, that we can place 3H together, then also we will be able to get 2 HH sequences. Okay, so these are two possibilities. But I think better method would be the same which we have done there. So we are having 1, 2, 3, 4 runs of H. Okay, and let us write this as X plus Y plus Z plus W, and we want 2 more H to be added, isn't it? Either you can give 1 at 2 different places, or you can give 2H at the same places, but you have to give 2H to these 4 places of H. And already, please understand, there is no condition of greater than or equal to 1 as it was there in that question. Here you can see X, Y, Z, W can be greater than or equal to 0. So we can write that Beggar coin method directly. 2 plus 3, 5 C2 I think. So that is 10 here. Similarly, if we want 5T, that means I have to give 5 T's to this 1, 2, 3 and 4 places. So once again, P plus Q plus R plus S is equal to, how much will it be? I think we want 5. So 5 plus 3, 8C2. 8C actually 3. 8C3 here. It should have been also 3, but 5C3 or 5C2 same thing. So 8C3, and how much is 8C3? Is I think 56. So if we multiply these two, we will get the answer. So 10 into 56, so answer has to be 560. So this completes the question, this completes the solution of this question. Now coming to this question, this I have taken from ISI UGB of this year only, 2020. And one very interesting question, please see what it is. Consider a board having 2 rows and n columns. Okay, 2 rows and columns means it will be something like this. Two rows and first column, second column, third column, fourth column, and so on, and this is the nth column, and we have to fill them by 0 or 1. Each cell is to be filled by 0 or 1, and there are 2 n cells in the board. So my A part, in how many ways this can be done such that each row sum and each column sum is even. Okay, so what we will do, please understand, we will start filling row 1. We will start filling row 1, and I have 2 ways to fill my cell 1, either 0 or 1. Either 0 or 1. I think this I can keep on doing. This is my n minus 1th column. This is my nth column. This I can keep on doing till n minus 1, because till this point of time we still have one more cell to go which can make sure that my sum will be even. Okay, so for R1, I think my first cell can be filled in 2 ways, second cell can be filled in 2 ways, and so on, and this will go till n minus 1 times. Okay, now please wait till n minus 1. Now calculate the sum. It will be either even or it will be odd. Depending upon whatever is the sum till this point of time, we will fill my nth row in exactly 1 ways. If till this point of time it was even, I will put 0 here. Till this point of time it was odd, I will put 1 here, so that my sum in this row 1 becomes even. So to fill row 1, I think we have 2 power n minus 1 ways. Okay, now because we have to make sure that each column sum is also even, so if I have filled my first cell of row 1, depending upon what value I have taken, whether it is 0 or it is 1, I think this second cell of column 1 will take or can take only one of the value. If it was 0, it will take 0. If it was 1, it will take 1 only. You do not have any choice. So in that R2 my first cell will have to be filled by one way, and I think one all the cells will be filled by one way only, so it will be 1. Okay, so total would be 2 power n minus 1. Now there is one more thing to notice here, please listen carefully, that when I was doing this 1 into 1 into 1 into 1, I was only focusing on that sum in all the columns becomes even. I didn't uh, give a notice to whether sum in the row 2 is also becoming even or not. But please understand, this will be automatically taken care of because uh, in that row 1 sum is already even. Okay, and here sum in all the n columns are even. Okay, so the grand total sum, if I say grand total sum, which we can calculate by adding the totals of columns which all are even and so on, so grand total sum has to be even only, isn't it? Because you are calculating even n times. And because we have already made sure that first row is having sum even, so sum of second row has to be even only. So this will automatically make sure that second row is also having sum equal to even. So final answer I will say is 2 power n minus 1. Now coming to B part. I think B part is also similar to this only, very small difference. I'll tell you what is the difference. Please see. In this we are given in how many ways this can be done, that each row sum and each column sum is odd. Okay. Now I think our starting should be same. So if I start filling R1 B part, it will be 2 into 2 into 2 and so on n minus 1 times. And this time, after knowing the total till n minus 1th column, we will take a call whether I have to take 0 or 1, but this time it will be opposite. If sum till n minus 1th cell is even, I have to choose 1 here. If sum till n minus 1th column is odd, then I have to choose 0 here. So last cell will again be filled in one way only, so it is 2 power n minus 1. Okay, now for R2, once again it will be 1 into 1 into 1 and so on. So it looks like same calculation, but please understand there will be a difference. Suppose your n is odd. Suppose your n is odd. Okay, then what will happen? That sum, or I should say grand sum, will be equal to we will be taking the sum. We will be odd one and so on odd one. In fact, all these odd one will be equal to 1 only. Odd 1, odd 2, odd 3, odd n, and odd n minus 1. So grand sum, if I take this along, now coming to this question which I have taken from ISI UGB of 2022. Very interesting question, please see. It says consider a board having 2 rows and n columns. Thus there are 2 n cells in a board and each cell is to be filled by either 0 or by 1. So this is how your diagram could be. One, two, three, 4 and so on, n minus 1 and n. This is my row 1, this is my row 2. And my A part says in how many ways this can be done such that each row sum and each column sum is even. Okay, now I think I have a choice to fill first cell by 0 or by 1. 2 ways. Next can also be filled by 0 or 1. 2 ways. and so on. I think I can fill my nth cell also by 0 or 1. Now after knowing what is the sum till n minus 1 cell, it will be either even or it will be odd depending upon how many times 1 has been taken. Okay, so 2 into 2 into I think n minus 1 times. So if sum till this point of time is even, I will put 0 in the last cell. If sum till this point of time is odd, I will put 1 in the last cell. So for last cell, I have just one choice, whatever may be the sum till this point of time. So R1 can be filled in 2 power n minus 1 ways. Now to fill R2, what we will do, as I have to make sure that sum in each column is also even. So if this first cell is having 0, I have to fill 0 here also. If this cell is having 1, then this cell will also have 1 here. So in all these scenarios, I think you can see row 2, every cell is having one choice. So 1 into 1 into 1 and so on into 1. So that will be 1. So total ways will be, total ways becomes equal to 2 power n minus 1. And that is the answer. I would like to tell you one more thing here, that because we have made sure that R1 is having some even, all the columns are having some even, but we have not checked whether R2 will also have some even or not. But I think this is automatically taken care of. Please see how. That if I write sum of R1, it is already even. Okay. If I write sum of column 1, sum of column 2 and so on, sum of column n. As we have made sure they all are even. So this will be actually even n times, isn't it? Even n times is nothing but even. And that should be equal to sum of row 1 plus sum of row 2 also. Because if you add all the elements in columns or you add them into the rows, the sum should remain same. So this sum of R1, which was already even, so this will make sure that this S of R2 is also even. So there is no contradiction. So we get our answer as 2 power n minus 1. But there will be small difference in the B part. Please see. This B part says in how many ways this can be done such that each row sum and each column sum is odd. Okay. So this time we want sum to be odd. Method will be same. Please see. So I have first column, second column, third column, fourth column and so on, n minus 1th column and nth column. So to fill R1, this time once again in this B part, I'll fill first cell by 2, 2, 2 and so on n minus 1 times. And once again, the last one will be filled accordingly. Whether sum till this point of time is even, then it will be 1. If sum till this point of time it is odd, then it will be 0, so that sum becomes odd. So filling R1 will be done once again in 2 power n minus 1 ways. And then R2. If here you have 0, then it has to be 1. If it is 1, then it has to be 0 and so on and so on. So I think R2 once again we have 1 into 1 into 1 and so on, one way only. So total would be, it looks like 2 power n minus 1, same answer. But there is a small difference here, please understand. As I told you, sum along R1 plus sum along R2 has to be equal to sum along column 1 plus sum along column 2 and so on, sum along column n. Okay, now two cases I will take. Suppose n is odd. I will take first when n is odd. Then you can see this right hand side will become odd, yes or no? Because all these sum are odd, and odd getting added odd times will be give you odd. But left hand side, we want this to be odd. We have made sure this to be this to be odd. So SR2 cannot be odd, or let me put it as LHS should also be odd. So this SR2 will become even. This SR2 will become even. That means it is not possible to have both rows sum to be odd if number of columns are odd. So in this case, it is not possible. So in this case, when n is odd, so my answer will be, so total number of ways will be 0. It is not possible. Okay, then coming to second scenario when n is even. In that case, I think it is possible because my right hand side will be even and this will give you SR2 also even. Sorry, this will give you SR2 also to be odd because SR1 was odd, right hand side is even, so SR2 will be odd. So in this case answer will be 2 power n minus 1 and in this case 0 will be the answer. Now coming to the last question. This question I have taken from one very interesting and important concept called as recurrence. Please see what this question is. A box has 14 balls, 7 black balls numbered 1 to 7 and another 7 balls, white balls numbered 1 to 7. So let us write balls B1, B2 and so on B7 and white balls at W1, W2 and so on W7. A person picks 2 balls at a time and repeats the process till box is empty. So I think 7 times he has to do this. In this 54th question, it says n be the number of ways of drawing the balls when every time he picks ball of both the colors and difference of numbers appearing on them is at most 1. So what exactly this question is saying, that whenever you are choosing a black ball, another has to be white. And here with BI, it could be either WI or with BI, it could be WI plus 1 or with BI, it could be WI minus 1. That is the possibility. Okay, now I will do this question in 2 parts, please understand. First, I will make the combination of black with white balls and then I will arrange them. Okay, so by making combination, I mean to say that like you can place B1 with W1, that is one possibility, B2 with W2 and so on. Let me just make one easy case when all 1 is coming with 1, 2 is coming with 2 and so on, and later on I can make permutation in 7 factorial ways in which maybe B2 W2 can come first, B7 WC and W7 can come second and so on. So first I am trying to make the combination of black and white balls which are permitted to go together, and then we will be doing the arrangement in 7 factorial. Okay, to make these combination, I am calling that let number of possible combinations to be equal to A7. 7 I am using from that number 7 for each color balls. Okay, if it would have been 6, I will take this as A6. If it would have been 5, I would have taken this as A5 and so on. Now please understand how this question will be approached. Now there are, I think, 2 scenarios for B1. Please see what are those. B1 will either go with W1. Okay, then I am sure you will understand this question after B1 is combined with W1. Now you will be left with 6 balls B2, B3, B4, B5, B6, B7 and 6 balls of white W2, W3 and so on. So isn't this tell me if B1 and W1 are combined together, then combining the remaining 6 balls of black color with 6 balls of white color in A6 ways? And if you are combining B1 with W2, because B1 can go with W2 or W1 only, it cannot go with W3, and we are not having any W0 either. So B1 will go either with W2 or W1. So that is the second scenario. But in this case, I'm sure you will understand W1 will not have any choice other than B2 to go with. Because if W1 doesn't go with B2, and already B1 was taken with W2, then W1 ball cannot be taken out with this condition that difference is at most 1. So I am sure you all understand that if that is the second case, then we are now left with 5 black balls, 5 white balls, and they will be combined in A5 ways, isn't it? In the beginning only I told you what is A7. A7 was the combination of was the possible combination of black balls and white balls with that condition given in this question. So isn't that A7 is equal to A6 plus A5? As you know, B1 can go with W1 or B1 can go with W2. So I have taken care of both the cases. So this way I think this question is done. Every time you can write this thing using the similar concept that A6 will be A5 plus A4 etc. Now what is to be done now? I think we have to write A1. That is very easy to say. It will be just one, isn't it? Because B1, W1, just one way to combine them. A2, if you do, it will be either B1 will go with W1, B2 will go with W2, or you can do cross. So there will be two combinations. Let me write what I am talking about. B1 with W1, B2 with W2, or B1 with W2 and B2 with W1. So A2 will be these two. And then we will use this relation which we call as recurrence relation, which is based upon the values of previous numbers. So A3 will be 3, A4 will be 5, A5 will be 8, A6 will be 13, and A7 will be 21. Okay, so what will be the final answer? Let me write it here. Yeah, let me write it here. So what will be the final answer? Because we have to arrange them also. So final answer n would be this A7, that is 21 into 7 factorial. And they are looking for n upon 5 factorial. So it will be 21 into 7 factorial upon 5 factorial. So this comes out to be 21 into 42. I think it comes out to be 882. Yeah, 882 will be the answer for this question. Okay, this is one part. The second part says let n be the total number of ways of drawing the balls when every time he picks the balls such that difference of number appearing them is at most 1. This time difference is at most 1, but ball can be any color. Okay, so I think this question is just the extension of this part. Okay, and you should be able to do this question after knowing the solution of first part. I will take this second part in my next session, in which I will be actually dedicating my session to recurrence method only. I will tell you many methods to solve such relations also, and I will take many such questions also. Okay, so now this is the time to give you the teaser question of this session. Those who are preparing for JEE Advanced this year or next year or maybe next year, you must know about Vedantu Olympiad. It is one big thing in online domain. If you know it already, fine. Otherwise, please Google it. You will come to know. Now coming to this thing, this is the link of topper notice board where we are putting all the relevant information about new batches coming up or new things going on. So please follow it. This is the QR code for the same. If you are going to appear JEE Advanced this year in 2022, please join the Telegram channel using this link or this QR code. It will take you to a channel where we are putting all the important information regarding Eklavya 2022. Similarly, for 2023 aspirants, this is the link and QR code for the channel of Telegram channel where all important informations are put. And similarly, 2024. We have also created one YouTube channel with the name V Impact, where you will be able to find the solutions of JEE Advanced, KVPY, and also we are going to put ISI and CMI very soon. Okay, so please visit this YouTube channel to know the solutions of question. In fact, you will find alternate solutions of almost every questions. We have put solutions question wise. It is not that entire paper is solved in one go. So you will find these solutions unique. Now coming to the teaser question. This question says find the value of MC0 x plus m raised to the power m minus mc1 x plus m minus 1 power m plus mc2 x plus m minus 2 power m and so on. In the end, plus minus 1 raised to the power m mcm x power m. You can see alternate plus minus sign. Power always here is m, but in the base x plus m, then x plus m minus 1 and so on, it is reduced every time. So you have to find the value of this. Those who can solve it, do not forget to send the solution to this email ID eklavyaSupport@vedantu.com with the subject line teaser solution maths. If we find your solution to be good, we will contact you and you will be part of the program going on with us. So that is all for today. Thank you so much. Bye everyone.